Now let's talk about throwing something in a gravitational field on the surface of the Earth in a diagonal. So the principle of the way we think about things is that if I'm throwing something both vertically and horizontally, then the vertical and horizontal movements are independent of each other. Of course, in real life, the air friction would make them connected, but in this abstract model, they are not connected. So so if I'm throwing something up at 10 meters per second, we saw in the previous video that after 2 seconds it will drop in my hand. But if I throw it at a 45 degrees angle, so that I'm throwing it up at 10 meters per second and forward also at 10 meters per second at the same time, so of course its total velocity is greater than 10 meters per second, but we're not interested in its total velocity at the moment. You can think about that later. But what we are interested in is how much will the ball travel forward until it hits the ground again. So remember, I'm throwing it up at a velocity of 10 meters per second, and simultaneously I'm throwing it forward at a velocity of 10 meters per second. Okay, so here's the solution. If I'm throwing it up at a velocity of 10 meters per second, as we saw in the previous video, it will drop back in my hand after 2 seconds. So the time that it would take it to hit the ground again is 2 seconds. I'm assuming that my hand and the ground are the same here. But during those 2 seconds, it was also moving forward at a velocity of 10 meters per second. So it would have moved forward during its flight a total distance of 20 meters. This is a very common question in high school or middle school physics. They ask it in a huge variety of ways. Supposing I'm standing on a train and I'm throwing something this way, or I'm throwing it out of the train, or I'm throwing it out of the plane. But it's basically all the same, that there are vertical and horizontal velocities and they are not connected.